guys, today we'll be learning about fusion energy. So that we all know there are many ways to make energy, such as there is nuclear fusion or renewables or even burning coal, gas and many other things. Well, however, there is a problem with fossil fuels, oil and gas as they pollute with carbon dioxide. This causes a huge problem in the atmosphere as it's a greenhouse gas which traps heat, and that carbon dioxide kills a lot of people. Millions of people suffer from it. Or there is renewables which don't emit any of these. Unfortunately, not every day is windy. Running water is not always available, and neither is there sunlight every day. So how about we use batteries? Unfortunately, there is not enough batteries or battery storage to store that much. Now, there is one way of making energy which also happens inside stars. That is called as fusion energy. Let's see how's the process and how are the processes we can do it by ourselves. Now, you see that the principle of fusion energy is quite simple. Now, we have a simplified atom here. It's simple with an electron and nucleus. Now, inside a star, it is incredibly hot. Because of this, the nuclei and electron are stripped off each other. They're stripped off each other. Now, since all nuclei are positively charged, they repel each other and they don't like each other. Now, you see, those two nuclei have to fuse. So, to make this happen, pre- pressure inside the star makes them merge into heavier nuclei, and in this process, they release energy. Now, there are two ways of doing this, such as internal confinement and magnetic confinement. So, first, let's be learning about the infernal confinement. Now, inertial confinement uses lasers to heat up a pellet of fuel, making it hot enough to fuse. Now, the second way is magnetic confinement, which uses an electric current, making it hot enough to fuse the plasma, which would make it release energy. One project like the ITER in France uses the magnetic confinement method. However, one of the most powerful lasers in the world, which is in the USA, is used for fusion experiments. Now, why the so how can we make the gas? What are the gases required for the fuse? Now, we do need hydrogen, but not any plain old hydrogen. We need a specific hydrogen called as deuterium. Luckily, deuterium is everywhere. We could be found in seawater very easily. However, tritium is harder since it's incredibly rare and there may be only 20 kilograms of it on the whole planet, mostly in nuclear warheads, which won't do much of good. However, there is another substitute for tritium, which is helium 3. However, helium 3 is also extremely rare on Earth. So, but the moon has an answer for this. After being stripped of after being hit by cosmic rays, it has built up a dusty layer of helium 3 which can be mined in using for fusion. A good idea to start a moon base as well. Now, why the wait? Well, that's simply because it's like playing $100 billion gamble. It's a $10 billion gamble. It's not $100 million gamble. It's like a $10 billion gamble. Who wants to invest that much money just for a simple experiment? They're just experienced. They haven't proven themselves yet, which is also why you haven't seen fusion energy anywhere. This money could be rather invested to renewables which have already proven themselves, or better off nuclear fusion, which its circumstances could be avoided if safety circumstances are followed. However, thank you for viewing this video, guys.